Alright, evaluating definite integrals again. I guess this is part 2. Now, we're going to do this with a sine curve this time. Same deal as last time. So, first of all, we need to integrate this. So, the integral of sine x on 6 is going to be, it's going to be negative cos x on 6. Now, normally I need to divide, by whatever the coefficient is. In this case, it's 1 on 6. And if I divide by 1 on 6, I'm going to get 6. So there's my integral, and my integral between 2 pi and pi. Now, putting that into my formula now, where I sub this in and then I subtract this. So it's going to be negative 6 cos 2 pi on 6. I don't really need those brackets there, so I'm just going to leave them out. And I subtract the rest of it, negative 6 cos, subbing this value in, pi on 6. Alright, again, you need to be careful with your negatives, that's why I like to put those brackets in there. Okay, 2 pi on 6 is the same as pi on 3, so I'm just going to write that. Negative 6 cos pi on 3 minus... now, cos pi on 6. Now, I should know what cos pi on 6 is because I can draw my standard triangle. That's pi on 6. Pi on 6 equal cosine, so it's adjacent over hypotenuse. Adjacent over hypotenuse, root 3 on 2. Alright, so that's negative 6 times root 3 on 2. And now I need to know what that is as well, cos pi on 3. Alright, that's pi on 3 there. Adjacent over hypotenuse, so 1/2. So it's negative 6 times 1/2 minus all of that. So minus minus, which means it's plus 6 root 3 on 2. Okay, so negative 6 times 1/2 is negative 3, plus 6 divided by 2 is 3, plus 3 root 3. I think that's my exact answer, negative 3 plus 3 root 3. I can't really go any further than that. Your textbook might I don't know, maybe do something like negative 1 plus root 3, or root 3 minus 1, or something like that. But I think that's about as far as I can go. I can put it into my calculator, and I'll get 2.196. So I'll just put an equal sign, equal sign, equal sign, equal sign, equal sign, equal sign. Okay, that is another definite integral. Let's do another one just for fun. Alright, so I'm evaluating between 1 and negative 1 the integral of e to the 3x minus e to the negative 3x with respect to x. This would probably appear with some brackets around here. Doesn't change it, what we're doing. Alright, it's going to be a miracle if I get through this because it's so... it's clear to me that I'm going to make mistakes because this is so similar to this with this negative in here. I'm going to misplace a negative, something like that. So just be really, really careful when you get started on this. Finding the integral here, so dividing by the derivative of that, so it's going to be 1/3 e to the 3x, and then it's going to be divided by negative 1/3, but if there's a minus there, so it's going to end up being positive. Positive 1/3 e to the negative 3x. And then all of that's going to be between 1 and negative 1. Now all that remains is to sub 1 into that, minus sub negative 1 into that, and then calculate. Put some equal signs here. Alright, so putting 1 in, I get 1/3 e to the 3 times 1, plus 1/3 e to the negative 3 times 1. And then I'm subtracting 1/3 e 3 to the negative 1 plus 1/3 e negative 3 negative 1. Whew. Okay, I don't think I need a calculator here because I get a feeling that something weird's going to happen. Because 1/3 e to the 3 plus 1/3 e to the -3 minus, so it'll be minus that, minus 1/3 e to the -3, that'll be minus that, minus 1/3 e to the -3 times -1 is 3. Okay, 1/3 e to the 3 minus 1/3 e to the 3, they cancel each other out. 1/3 e to the -3 minus 1/3 e to the -3, they cancel each other out. I think the answer is 0. Bit of a weird trick question there. It looked really, really ugly, but it kind of all just sort of balances itself out in the end. Of course, that's assuming that I've put all the negatives in the right spot. Alright, that's evaluating definite integrals part 2. I keep talking about negatives and sort of getting mixed up, but there is a lot of work to be done in these, so you need to be really, really careful and very, very exact in how you're doing them, because one mistake sort of tears the whole thing apart.